Lesson 2. Jet Aircraft Systems and Architecture. Modern transport jets rely on deeply integrated mechanical systems. Let's examine a high-bypass dual-spool turbofan engine. It features two mechanically independent spools on concentric shafts. The low-pressure spool, or N1, uses the low-pressure turbine to drive the front fan and low-pressure compressor. Meanwhile, the high-pressure spool, or N2, operates at higher speeds, using the high-pressure turbine to drive the core compressor. These engines also supply pneumatic bleed air. At low power settings, air is extracted from the high-pressure bleed valve. However, during high-power phases like takeoff and climb, intermediate pressure air is sufficient. To protect pneumatic ducts from extreme pressure and thermal stress while saving fuel, the high-pressure valve automatically closes, leaving the intermediate pressure valve to supply the system. Bleed air is crucial for environmental control, including cabin pressurization. At high altitudes, pressurization controllers maintain a comfortable cabin environment by continuously admitting conditioned bleed air while automatically modulating cabin outflow valves. Closing the valve lowers cabin altitude by increasing pressure, while opening it releases air overboard to raise cabin altitude. In the hydraulic system, you will often find a power transfer unit, or PTU. The PTU provides a brilliant safeguard. It uses a hydraulic motor driven by pressure from one isolated system to mechanically turn a pump in a second system. This allows bidirectional power transfer without any actual fluid mixing between the two systems. Finally, safety systems like the lower cargo compartment fire suppression rely on HALEN 1301. If a fire warning occurs, an initial high-rate discharge quickly knocks down the flames. This is followed by a metered slow discharge to maintain a fire suppressant concentration, preventing reignition for up to 3 hours during long diversions.